Okay, so let's talk a little bit about statistics, at least for this year, 2021. We're going to actually skip this first lesson in 11.1. Seems like it's just all about vocabulary. So you've got like this parameter, it's a piece of information. Statistics is when you have to have a sample or a subgroup of a population, and you're going to do some analysis on data. That's my interpretation. Category of data is like a number. Quantitative is like when, or I mean, quantitative, categorical is like when you have an answer that's not a number, like a word or something, and quantitative when you have a number answer. So it's just like stuff like that. A statistical question, because it can be answered, many pieces of information being the key. And so you know, the one that's just like linear perfect, it's probably going to not be, because it's being, in this case, calculated on it. When you got a random, but you can still see patterns. So that's a statistic. A statistical variable is the same thing. Quantity category is sort of like, I just think of it as it wouldn't have to be, but like a word. Anyway, so let's get up to where you're going to actually answer some questions using all this vocabulary. If you want to go back and look at those, they're in your book from that 11-1. So you have three types of studies. And the three types of studies are a sample survey. You know, you're asking a group of people. And in here, one of the key features that I always key off from here is that the subjects are randomly selected, like from a population. So you're randomly selecting the people. In the experiment, you're going to randomly assign them to two groups, and those groups, one of them gets a treatment and the other one's like a control group. And then the last one is an observational study. You're just, there's no randomization. You're just looking at the people that happen to come by or that end up in your study. So those three types. Then when you go to the types of sampling, stratified sampling, if you have two subgroups here and they have a mixture of all the different types of characteristics, versus like here where you have cluster sampling, you're going to take from each group, but your groups some way are already kind of in, they have characteristics within them where they're already grouped. And then you have over here your systematic sampling. Everybody's just mixed up and you're randomly choosing from all of that population. Over here, convenience. So just who happens to be in a certain place at a certain time that you're choosing from. And then even the one that's even the more, just when people volunteer. So definitely over here, since you're not randomly selecting, you've basically got a real high risk of bias, and every place you have a chance of having a bias you want to try to control for. All right, so what type of study? A gym asks its customers if they would prefer the gym to open earlier in the morning, or a gym tries out a new weightlifting method to see if it would build muscle for their customers faster than their current method, and a gym counts the customers who come before 8 a.m. So which of the three types of studies? So obviously the last one, there's nothing you're doing there. It's just whoever shows up. So that's going to be your observation. The new weightlifting method, you are going to randomly assign people into the two types of group. So there's your observational study. You can put trying it out, you can have your experiment. And then your last one, the survey, you can randomly choose people if they would like to have it open earlier in the morning or not. So that's your sample survey. So let's see, just a reminder, the bias. So in this example here for bias, you go out and survey people. You've got 100 people that are out on a sunny day, ask them if they're happy. Or you have all these crowded people in the subway on a Monday morning, we're bustling and bustling. That's definitely got bias built into that study because of the environment in which you're asking the two questions. Let's go ahead and, so then we have a simple random sample. So the simplest way to use randomness, a simple random sample, each member of the population equally likely to be chosen. So everybody's mixed up and you're just randomly choosing from the whole population. Okay, so everybody's all mixed up and you're equally choosing. Then let's see, what sampling method used in these examples? Let's see, you can read through those. That's all explained on that slide. An experimental group and a control group. So your experimental group, so you have, this is an experiment. And you have these two groups. One of them is going to get whatever you're trying to test for, and then one of them gets nothing or a placebo. So sometimes this may be like the classic sugar cube. This one might be like your classic, whatever the thing is that you're testing for. And so sometimes this one, and back in like the Salk studies for polio, they gave them like a vaccine that was just like a saline, where this one got the vaccine that they were testing for. And then that wraps it up, your 3 types of studies. So moving on from there, we're going to do all these at once, 11, 2, 3, and 4. So skewed left, normal distribution, and skewed right. Notice your measures of center. Your mode here is actually maybe not a bad choice for what you use for your measure of center. Median, more likely, because when you're skewed one way or the other, your mean gets pulled off in that direction, doesn't really measure your center. So usually here, you're gonna want these skewed in those two. You're gonna wanna use your 5-number summaries. Remember, you get your box and whisker, your median in the middle, your lower quartile, upper quartile, and you go down to the min and up to the max. We'll look at an example more. And then for this one, you're going to use your standard deviation with your mean when you have a normal distribution. All right, so moving on from there. So standard deviation, we'll use technology. We'll see an example of that later on. To find that at this point, we're not going to use the complicated formulas. So your 5-number summaries, here's an example. Remember, to get the middle number here, you find your median. So work your way to the middle of the data, crossing these off as I go till I get there. And so I believe it's between those two if I crossed them off evenly. So that's my 12.5 right there. Then if you find the middle of each of those 2 sets of data, so the middle of here, if you start crossing those off, you'll find your lower quartile. So it's right in between those 6s. So this should be at my 6. Looks like that's correct. And then my upper quartile on the other side. So 16.5. Oops, I forgot to cross that one off. So that would have came off, it would have been between there, 15.5 for my right there. And then your max and your min. Okay, so there's your 5-number summary. I always like to point out that that means that half of your data is in the box. That's why they call it quartile. So if you go from here to here, that's half of your data, and then you got half of it outside of there. So that lets you, and then this, remember this part in here is your inner quartile range. If you take 1.5 times that, whatever that number is, how far those are apart, and you go out this far, that sets your boundary for, this is the standard way of calculating for outliers. So if you take that, whatever this is, 15.5 minus my 6, so that's what, 9.5? If you take 1.5 times that, go that much below here and that much above here, that tells you how far you go, and if anything's beyond that, it's considered an outlier. All right, so we kind of went through that. There's a practice problem that could be done. Your skewed distribution, we were looking at that, and your symmetrical, so your skewed left, skewed right, and your normal distribution. Again, here we're going to use our box and whisker, or 5 number, and here. And then if we were using this one, we're going to be sticking to the mean and the standard deviation, because if you go out, your standard deviation on each side, that gives you 2/3 of your data between there. All right, so then after that, so here is my normal distribution, and it's equally or pretty much symmetrical. So in these, this one doesn't look like it has any, you know, it doesn't tail off on either side, neither end is bigger. So I would call this one neither or none. It's not normal. If anything, you might say it's more normal, then it's definitely not skewed. This one would definitely have a skewed right or skewed left look to it. And obviously this one would be my skewed right. So it's higher on this end and then goes off to the right. Okay. And that wraps up those. Okay, so now your new lesson talks about the empirical rule, which is the norm for, it works for normal distributions. So when you have symmetry, and it has your standard deviation, one standard deviation away from the mean, this mu, that's for the Greek letter for mean. If you go out 2 standard deviations on each side, it's 95%. And then this one isn't labeled, but these are the 3 there and there, and that's 99.7% of your data is between there. All right, so let's continue. This formula here is how, and it's, some people just memorize the formula. If you understand what it's saying, it's called the z-score. And really what you're figuring there is how many standard deviations you are above and below the mean. So we're going to see that in a little bit. And if you understand it without the formula, awesome. If you need the formula and memorize, that's perfectly fine. All right, so here we have an example. Your mean is 40, so that's like in the middle. If you come out here to 42, that's 1 standard deviation above the mean. And this 38 is 1 standard deviation below the mean. And then the empirical rule says roughly between there we have 2/3 or 66 and 2/3%. That's actually more like 68%. So 34 above and 34% below the mean. Okay, so if we said how many or what percent is between 38 and 42, you would say 68%. If I said what percent is below the 38, well, if there's 34 here, 40 would be the 50th percentile. And if there's 34 there, what's left below that is the one way to do this. So you could have your 50th percentile here. We said 34 in here because 68% between. So if I take the 34% off from here, that leaves what, 16%? So below here would be 16%. That's just one way to work with it. All right, continuing with that example, it says, what about from 33 to 48? Well, where's 48 inches? 48 inches isn't even on my chart here. 48 would be the next one up, right? So that's 1, 2, that'd be 3 standard deviations. So we know that in here, for example, was 68. We know that from here to here was like 95. The empirical rule. I don't have that on this screen. Oh, there it is, the 95. You know, and then when you go out 2 to 3 standard deviations, that's the 99.7%. So let's see, if we already figured on the last screen that below, let's see, what percent, because we're supposed to be answering 33 to 40. Well, 33, I don't have 33. Oh, 33 is out here again as well. So 33 to 48, that's my 99.7%, because it goes out 1, 2, 3, actually that's 4 standard deviations. 1, 2, 3, 4 standard deviations, which the Chester's range from which with a mean measurement of 40, standard deviation is 2 inches. Okay, so that's just saying, yeah, that we weren't supposed to find the percent. If it did say from 34 to 46, that would be my 99.7% of the data. All right, recent SAT scores. So now this is a common example that they oftentimes use. So you've got, it's talking about SATs. You've got a mean of 508 and a standard deviation, your standard deviation of 121. So you see your mean here. You see your standard deviation of 121. And if you go below the 508, 121, you'd be at 387. If you go above it, 629. And it says what percent fall between here. So with the empirical rule, that's 68%. Okay. And then sketch a graph, 387 to 629. There we go. Moving on. It says, so below the 387, like we said before, would be 16%. Above the 629, there would be 16%. So this one says between 266 and 750, that's 2 standard deviations out, so that's 95%. And then the 266 to 629, so this is 16%, and that 68, that's how I would get that because it's already on my screen. So that would be what, 84% of the data. All right, so now they come up and they say, in case you get some other number that's not one of your exact, they give you this formula. So figure out how far you are from the mean, divide by the standard deviations, and that would tell you basically how many standard deviations you are away. So in this problem, we've got 2 girls. We've got Ella and Alicia. One took the SAT, and she got a 1380. That was Ella. And then we have Alicia, and she took the ACT and got a 32. So then the information for the ACT, a 21 is the standard deviation, or I mean is the mean, and then a standard deviation of 5, and then color coding these as I go here. And Ella's SAT, that has a mean of 1,000 and a standard deviation of 200. So what they do is they call this the Z-score, a standardized score. If you figure out how many standard deviations they are above or below the mean, then we can compare these to each other. So Ella's 1380 minus the 1,000, that means Ella was what, 380 points above the mean. And if each standard deviation, you know, to get to the 2/3 of your data, if that's 200, that means she was 1.9 standard deviations above the mean for Ella. And remember, Ella was the SAT. And then if you go over here and talk about Alicia, she scored a 32. That was her score. The mean on there is 21. So that's what, 32 minus 21 is 11. But when the standard deviation is 5, that gives her 2.2 standard deviations above the mean, or they call that the Z-score. So the 1.9 and 2.2 are the Z-scores. And so that would mean that Alicia did better, comparatively speaking, than Ella. All right. These are like curves. You can't say it's linear. It doesn't change the same amount as you go. So when you're working on that, you're going to get these tables that look like this. So if I get a 1.85, this table's a little easier to read, I think, because here's your 1.8, here's my 5. So if I find where those meet, right here, that's my percentile, the 0.9678. So a 96.8%. And then the other one, if you look at it, it's a little bit more confusing because a 1.85, when you look here at the 1.85, you're going to end up on that with a 0.468. Well, how does that work? Well, that's because your mean, knowing your mean is the 50th percent. And then this is above the mean, so you just, that's how much to add on, the 468. So that's where you get the 968 here. So that would be 96.8% here. They just took it out one more decimal over here, 96.78 if you wanted to be a little more accurate. So that's how you read those two tables, and that would be the percent. There's 96.8% below that, whatever that data point is. That's your z-score, the number of standard deviations above the mean. And that wraps up how you do the statistics unit.